this presentation you will have outlined to you some key considerations that should be made when carrying out a data capture exercise. There are a number of considerations to be made before capturing data, including the rationale for capturing the data, ensuring the fields have been correctly set up, linking the data to the local land and property gazetteer if the dataset contains address information, and determining the format in which the data is going to be stored. There are also a number of tools that are available to use to ensure the data capture is as reliable and as accurate as possible. Data can be captured as spatial or map layers with attached attributes, or simply as a table or database without any map objects. Data may be created directly in ArcMap, which is the application used by the GIS software license, or it may be generated in other applications, for example in Excel or an Access database. Before embarking on a data capture exercise, it is important that careful consideration is given to the type of data capture that is required and the content of the data that is required. What fields in the attribute data are to be included? Will these add value to the dataset? Who is the target audience for the dataset? Will their requirements be met? And how will the dataset be maintained in the longer term? If you would like advice about any of these aspects, please contact Nottingham City Council's GIS team. They will be happy to provide advice and support. Another key consideration of any data capture exercise is the issue of data protection. There are a number of data protection principles to consider. The third data protection principle states that data should be adequate, relevant and not excessive. If your data contains personal data, for example where individuals could possibly be identified, there are specific requirements to be met regarding the collection, storage, processing and disclosure of personal, including sensitive personal data, laid down by the Freedom of Information Act 2000 and the Data Protection Act 1998. Nottingham City Council seeks to comply with all the requirements of the Acts at all times. This includes all data of which the corporate GIS make use. Please refer to Nottingham City Council's intranet for further information. Many datasets that you use will contain address data. Any address data should reference the Local Land and Property Gazetteer, LLPG, which is the definitive listing for all addresses within the city. All authorities have a responsibility to maintain a Local Land and Property Gazetteer, which sets out common data entry conventions for address and property data. The unique identifier for the Local Land and Property Gazetteer is the UPRN, Unique Property Reference Number, and should be included in any datasets containing address data. At Nottingham City Council, address data can be accessed through Locator Hub, through ArcMap or online. The GIS team are responsible for maintaining the Local Land and Property Gazetteer and can provide support on setting up address data in the correct format. If the Locator Hub toolbar is not visible when you are using ArcMap, please contact Nottingham City Council's GIS team to have it installed. It is important that every item in a dataset, whether it's a point or line or polygon or even just a record in a table, has a unique identifier. In this way, each individual item is tagged, and this makes management, analysis and manipulation of the data much more flexible. Every dataset should have a field that contains a unique reference of some kind for each record. For datasets holding information about land or property, for example, the UPRN, Unique Property Reference Number, from the Local Land and Property Gazetteer could be used. One of the added value benefits of records having a unique identifier is that it can be used to join or relate the dataset to other datasets. It is possible to define the type and length of the fields that hold the data. There are guidelines for storing data spatially in terms of fields, the precision. The precision is defined as the total number of digits allowed, that is, before and after the decimal point. The scale. Scale determines the maximum number of decimal places and the length of a field. Please refer to the data management document that is available on the web for a full listing of field types. Field types and lengths set incorrectly can affect the file size, which can unnecessarily increase the storage space required, which in turn may affect performance, if not only that dataset but the whole of Nottingham City Council's corporate GIS. It is not recommended that you create data as graphics. A graphic is a shape which can be a point, line or polygon, but graphics do not have any attribute data. They are only visible to one map document and therefore cannot be shared. Data should be created as points, lines or polygons as map features or spatial objects in a map layer. Spatial objects do have attribute data and can be added as a layer into any map document and therefore shared. It is likely that for any data you capture, you will want to use it in other map documents or be shared with other GIS users. As proper spatial objects can have attached attributes, such as an address and a UPRN for a unique identifier, as already been mentioned, it makes the data much more useful. Graphics are created using the tools from ArcMap's drawing toolbar, but proper spatial data capture in a layer is undertaken using the correct editing approach and the tools and settings found on ArcMap's editor toolbar. If you have been used to using ArcGIS version 9.2, you will probably be familiar with shapefiles. Shapefiles is a key format for storing data layers for ArcGIS. However, file geodatabases is a format that is also available for storing data. Nottingham City Council's GIS team recommends that you create new datasets using file geodatabase format. Therefore, you are encouraged to become familiar with file geodatabases and learn more about how to create and use file geodatabases to store data. It is recommended that you watch the GIS 24/7's mini-module ArcGIS B titled GIS Data Structures. If you are using the ArcGIS version 10 software, creating file geodatabases is now the default option. A default file geodatabase is set up on your C drive when you create a new map document. You can browse to the H drive to set this up in your user folder. A file geodatabase contains feature classes, which can be organized into feature datasets, which are a collection of feature classes. File geodatabases have many advantages over shapefiles, such as that they have a smaller file size. They enable easy organization of datasets. The feature classes will take the projection of the feature dataset or file geodatabase automatically. Feature classes automatically add an area attribute where this is applicable. Shapefiles are standalone. Feature classes can be exported to shapefiles, and shapefiles can be imported into file geodatabases. Validation rules can be applied to ensure accurate capture of data using subtypes and domains. It is worth noting that file geodatabases are not compatible between versions 9.3 and 10, but data can be imported and exported between the two if needed. All spatial data needs to have a correct projection set to ensure it displays correctly in the ArcGIS software. All the spatial data used by Nottingham City Council relates to either Nottingham, its surrounding areas or some cases England, and will therefore be British National Grid projection. To see the projection, click on Properties and then Source tab in the software. A key consideration if you are undertaking a data capture exercise by digitizing data is that you carefully think about the accuracy of the data you require. For example, in capturing potential new development sites, it is likely you will capture data by copying or tracing around features from an existing base map, and the accuracy of this background data will determine the accuracy of the data you capture. Using large-scale maps, that is 1 to 1250 scale, such as master map, as background mapping to digitize the data will produce more accurate positioning of the sites. Using small-scale maps, for example 1 to 20,000, as background mapping to digitize the data will produce less accurate positioning of the sites. Digitizing at a larger scale will be more time-consuming, however, could produce results that are able to be used by a wider audience and also used in different web applications, simply because they're more detailed. However, there are a lot of useful shortcuts to capturing data from such a detailed source, such as copying features and then merging or splitting them. It is recommended that you look at the Advanced Editing with ArcGIS course from GIS 24/7 to learn the best methods plus all the tips and tricks for capturing data. Small-scale maps should not be used at large scale for data capture, and large-scale maps should not be used at small scale for data capture. After finalizing the design of the data capture, the actual data capture exercise can begin. If this is carried out as a desktop exercise in ArcMap, there are a number of tools which can assist in the accurate and reliable capture of the data. There are a wide range of tools, some of which are quite specialist for capturing certain parts of features. Again, it's recommended that you look at the Advanced Editing with ArcGIS course from GIS 24/7 to gain a full insight into the tools and processes involved when capturing and editing data. Also, the mini modules for ArcGIS 10, J, Editing Data, will give you a good introduction. Although there are a whole range of editing tools, two of the most useful tools will now be highlighted. The first is the Tracing tool, which is found on ArcMap's Editor toolbar. Tracing is a quick and accurate way of creating new segments that follow the shapes of other features. This is useful if you are using MasterMap as your base map. Tracing is particularly useful when the features you want to follow have curves or more intricate shapes. Tracing MasterMap should significantly improve the accuracy of your data. The second key editing tool is the Snapping tool. Snapping can help ensure that the features being created are connected to each other. Ensuring that features are connected is a really key element of ensuring that the data is captured correctly and the data is clean and subsequently edits are more accurate. To use snapping, it must first be turned on. It can be turned on for different editing elements such as the vertex, edge and end of features in each of the layers that are being used in ArcMap. This can be done on a layer by layer basis or by using the snapping environment window. Using these settings gives great control of how the snapping is undertaken. These settings will then control how the pointer moves or jumps to each of these elements. Enabling these options when using a base map such as MasterMap will greatly assist in the accuracy of the data capture. Another aspect to consider when turning snapping on is the tolerance that is used. This is the distance the editing elements need to be in relation to the pointer for the snapping to work. A greater tolerance results in more snapping, a smaller tolerance results in less snapping, but perhaps more control. Snapping is a key tool if you are creating a dataset that may be used for routing, perhaps using Network Analyst. Alternatively, if you're creating polygons, it will ensure that you do not have gaps or polygons that overlap. A final consideration worth mentioning in relation to the capture of new data is the merit of creating accompanying robust metadata. This will assist any other users of the data captured to understand it properly and to be aware of any possible limitations that it may have. The GIS team is available to support all Nottingham City Council's GIS users and can provide support to ensure the metadata is accurately collected and displayed for the dataset.